Okay, this is part 6 of our lesson on solving and graphing quadratic inequalities. If you put all these videos together, this has got to be the longest video ever for a math assignment. Anyway, let's get started. All right, so the first thing we need to do is we need to solve to find the X-intercepts, the zeros of the function. Now notice how all I have here is x squared. I don't have, for example, 2x squared plus 3x minus 4 is greater than 0. Oh no, there's no middle part, all right? It's just the 2x squared minus 4. Okay, whenever we have only one type of x instead of both, one option that you have is the square root. This is a problem that we could solve by doing the square root. So to do that, we try to get the x squared by itself. So the first thing you would do is you would add 4 to both sides, like this. So that's going to give you 2x squared is greater than 4. All right, and then we're going to divide both sides by 2. Okay, and that's going to give us x squared is greater than 2. Now here's where you would take the square root of both sides. I'm just going to leave a little bit more space than that. All right, time to take the square root of both sides. All right, so I'll take the square root of x squared, and I'll take the square root of 2. Don't forget, anytime you take the square root of both sides, your solution is going to be plus or minus. Okay? By the way, for right now, let's just do equals. Okay, anyway, so that's going to give us x is equal to, well, x is equal to plus or minus the square root of 2. But we could write this separately as x is equal to positive radical 2 or negative radical 2. So these are our two x-intercepts. These are the zeros of the function. Okay? Now, I'm going to have to graph these on the number line in a minute. But two things. Number one, when I graph these, am I going to use open circles or closed circles? I'm going to use open circles. Okay, because it's greater than. If it was greater than or equal to, then I would fill in the circle. Okay? So we will use open circles. Also, these square roots, this is probably not too meaningful to you in terms of where to put it on the number line. But if you need to know, just remember, we can always put this in the calculator and do the square root of 2. Okay? And we might toggle it, and we find out that it's approximately 1.4. So if you need to know, understand that it is approximately 1.4. So we're talking about 1.4 or negative 1.4. Okay? So keep all of that in mind. Now, before I do the problem, I need to say one more thing. No, I don't. No, I don't. That's it. Okay, so let's go ahead and graph these on the number line. Okay, where is my number line? Where are you, number line? I'm going to just do a simple sketch. So I'm going to put 0 here in the middle. Okay, and over here I'm going to put my negative radical 2, and over here I'll put my positive radical 2. Okay, please just keep in mind that this is approximately negative 1.4, and this is approximately positive 1.4. Okay, Now, we said we were going to do open circles. So I'm going to put open circle here and open circle here. Now, once again, let me show you how you could get the rest of the answer in about 30 to 45 seconds graphically. This is a parabola. It is an upward-facing parabola because it's positive. So what you could do is draw a parabola. Okay, so here's my parabola that has these x-intercepts. Okay, so it's going like this, and it's going like that. Okay, and these are the x-intercepts, like right here. Now, we want to know where the function is greater than 0. All right, now on this graph, greater than 0 means above the x-axis. So this part of the graph is above the x-axis, and this part of the graph is above the x-axis. Okay? Now, in terms of x values, let me make this a little smaller. All right, are these branches that I just highlighted in red, are they the branches, is that the part of the number line that's between the two x-intercepts, or is it the part of the graph that's going outside to the left and to the right of the x-intercepts? Well, you're looking at it. Like this branch is going to the left. So we could draw that as an arrow going to the left. This branch is going to the right. So we could draw this as an arrow going to the right. Okay, so graphically, you should be able to know the answer in about 30 seconds, okay, just by drawing a parabola. All right, but we're going to go back and do it using test values now. Okay, test value. So we have just divided this number line into 3 sections. We have this yellow section, all right, to the left of negative radical 2. We have this blue section, okay, going between negative radical 2 and positive radical 2. And we have this pink section, or red, to the right of positive radical 2. Okay, our x-intercepts divide the number line into 3 zones. We need to try a test value from each zone. I like to make a little chart to keep me organized in my work. I recommend you do the same. Okay, in each one of these zones, I'm going to pick a test value. So I need a test value to the left of negative radical 2. That means less than negative 1.4. If I go to the left of negative 1.4, the first integer I come to will be negative 2, so I'm going to pick that. In the blue zone, I've got 0, so I always use 0 when it's in the zone, baby. Now, to the right of 1.4, the first integer I reach to the right of 1.4 would be positive 2. So these will be the 3 values that I use as test cases. Okay, now, we have no factored form. Usually I use the factored form when I do this. But this problem was unfactorable, so I am going to use the original inequality this time. 2x squared minus 4 is greater than 0. I'm just going to use that. Okay, so I've got, what did I say? 2x squared minus 4 is greater than 0. I'm just going to put that in all 3 places. Whoops. Oh, that's supposed to be squared. 2x squared minus 4 is greater than 0. Okay, so let's do our test values now. So I need to substitute negative 2 in for x. If I were you, I would use parentheses when I substitute in. Okay, so I've got 2 parentheses squared minus 4. And inside the parentheses, I will put this negative 2. Now, be careful of your order of operations, guys. Do not multiply first and then square it. All right? Please excuse my dear Aunt Sally. All right? Parentheses, exponents. Okay? So exponents come before multiplication. All right? It's these two. So we have to square it and then multiply by 2. Okay, so this will become 2 times 4. All right, negative 2 squared is 4. Minus 4 is greater than or equal to 0. That's 8. Minus 4 is greater than 0. That's 4 is greater than 0. And then you ask yourself, is this true? Is 4 greater than 0? Why, yes, good sir, or madam. 4 is greater than 0. That means negative 2 is a solution. That means all of these yellow values are solutions. We will show that these yellow values are solutions by drawing an arrow like this. Okay, showing that all of the values to the left of negative radical 2 are solutions. Now let's do test value of 0. So okay. Again, you have to square it first and then multiply by 2. I guess it doesn't matter in this case, but 0 squared is 0. So I've got 2 times 0 minus 4, don't you know? 2 times 0 is 0, so I've got 0 minus 4, and so 0 minus 4 is just negative 4. And then you ask yourself, is this true? Is negative 4 greater than 0? No, no sir, I don't think so. All right, 4 is not great. Negative 4 is not greater than 0. All negative numbers are less than 0. That means 0 is not a solution. That means that none of the values in the blue zone are solutions. So I will show that by leaving this area blank. Okay, let's look at the final situation. All right, hold on. Okay. So I've got 2 times 4. Okay, again, don't multiply and then square. Square it first and then multiply. Okay, so 2 squared is 4. Okay, and then 2 times 4 is 8. 8 minus 4 is 4. And then you ask yourself, is 4 greater than 0? Oh, silly, of course it is. Of course it is. Okay? That means 2 is a solution to the inequality. That means that all of the values to the right of radical 2 are solutions. And we will show that by drawing an arrow to the right of radical 2. All right? All right, so here's how it went down. We had a yes, a no, and a yes. So we drew the arrows for the yes parts, and we left the no part blank. So this is the graph of the solution set for this particular inequality. Let's go ahead and write the solutions in interval notation, and let's see how it looks like using inequalities. So first of all, interval notation. When you have 2 separate parts like this, you're going to have 2 separate intervals. So for the left part, that's going to be, well, it's going from negative infinity to negative radical 2. So I will do negative infinity to negative radical 2, right here to here. Open circle, so leave it rounded. And then for this one, is going from radical 2 to positive infinity. You always have to go left to right. So on this one, a common mistake would be to go, oh, this one goes from negative radical 2 to negative infinity. No, you have to go left to right. You have to say negative infinity to negative radical 2. But this one will indeed be positive radical 2 to infinity. Okay, open circle, so leave it round. And when you have the two parts like this, we connect them with the union symbol to show that they go together. It's not two separate answers. Together they make one solution set. All right, so that is how you would write the solution using interval notation. Okay, with inequalities, it's still very easy. For the left branch, these are the values less than negative radical 2. So we could just say x is less than negative radical 2. For the right branch, this is showing values greater than radical 2. So I will just say x values greater than radical 2. And instead of a union symbol for inequalities, we use the word or. So that is how you would write the solution set using inequalities. On a test, I don't care which one of these you give me. But if it's a multiple choice situation, you have to be ready to recognize either one as the correct answer. All right, guys, that was part 6. 6 videos, 1 video per problem on this homework assignment. That had to be like 2 hours of video altogether. It's ridiculous. It's crazy. It's just crazy. But it's finally over. My God, it's finally over. I'm going to cry as soon as I turn this video off. But for now, I'm going to hold my emotions inside. I'm not going to let you see me be broken. All right, so I hope you appreciate my pain and suffering, and I will see you on the next video. I hope it helped.